Okay, so the properties that we've already talked about for just basic exponents, those are going to also apply to our rational exponent. So your rational exponent is just an exponent with a fraction. Okay, that's all rational means, is it can be expressed as a fraction. So your rules for your exponents, if I multiply like bases, I add my exponents. That's the same thing that's going to happen just now with fractions. Okay, if you have a exponent raised to another exponent, and power to a power, we multiply that. Same thing is going to apply just with a fraction. So all of these rules we've already discussed, okay? So I put these in here just for a review. So remember that if you have multiple terms with an outside exponent, you just distribute that exponent, and each term, no matter how many terms there are, whether you're multiplying or dividing, each term takes on that exponent, okay? Remember, you cannot multiply a base by an exponent. It's only exponent by exponent, okay? Now, your negative exponents, remember that means it's in the wrong spot. You have to flip it. So if it's negative in just like this, then you do 1 over. If it's 1 over a negative, remember that just comes up and becomes positive without a fraction, okay? If you divide like bases, then you're going to subtract your exponents. This is just telling you that if you have the nth root of multiple terms, you can split those terms apart. Okay? Same thing with a fraction. If you have the nth root of a fraction, you can split it to the nth root of your numerator over the nth root of your denominator. Okay? So your final answers should not have rational exponents. They should all be in radical form. I'm going to zoom in a little bit. So if I have x to the 1/2 times x to the 3/2, okay, I'm multiplying like bases, so I'm going to add 1/2 plus 3/2. You don't have to write that. I'm just going to show you what we're doing for the first few examples so you can see where we're getting this answer from, okay? Now, I'm not expecting you to do everything in your head. That you could do in your head, but you have a calculator. I'm not taking the calculator away. You can use your calculator for the fractions, okay? So 1/2 plus 3/2 is going to give me 4/2, which is x to the second power, okay? Remember, for you to add or subtract fractions, they have to have common denominators, okay? All right, if I have x to the 5/2 raised to the second power, I have an exponent raised to another exponent. Power to a power, I multiply. So I'm multiplying 5/2 times 2. Well, whenever I do that, what happens with my 2's? They cancel, okay? So that would just leave me with x to the 5th. You could have typed in 5/2 times 2 in your calculator and it'd still give you 5, okay? Now, these two examples worked out pretty good to where it gave you whole numbers as your exponent, so we don't have to do anything weird with it, okay? But if I have the next example, x to the 1/2 times x to the 1/3, okay? Whenever I go and I add 1/2 plus 1/3, okay? You can either do it by hand, get your common denominators, or type it in your calculator. 1/2 plus 1/3 is going to give you what? 5/6. Okay, so when I'm given my problem and my answer has a rational exponent, I'm going to have to put it in radical form. So remember the rule that we discussed last time, a to the m over n power, you can rewrite as the nth power of a raised to the m exponent. Or you can also write it as the nth power of a to the m. You can put that exponent underneath the radical also. Okay? It doesn't matter which way you write it, as long as if you need to simplify, you simplify. So for today, we're going to put it underneath the radical. Okay? So if I have x to the 5/6, then that denominator is my index, which is my root, and my numerator is the exponent. Okay? So when I rewrite it, I have my radical. I've got the 6th root of x to the 5th. Okay? And then I would see, can I simplify? My 6th root tells me I need 6 x's. Okay? But I only have 5. So I can't simplify that. That's my final answer. Okay? We good so far? Okay. So now I have y squared raised to the 3/4. So I'm going to multiply 2 times 3/4. And that's going to give me 3/2. Okay? So I need to rewrite it. So that's going to give me y underneath the radical. My index is a 2. I don't need to write that because it's understood to be 2 whenever I write a square root. Okay, so it's the square root of y cubed. Okay, can I simplify that? Yes. Okay, if I have 3 y's, that y cubed tells me I have 3 y's. My index tells me how many I need, so I need a pair of 2. So whenever I write it out like that, I can simplify it. Remember, when you simplify, your circles go on the outside. Whatever you pair goes on the outside. What's left over stays under the radical. So this is going to give me y square root of y. So when you have your rational exponent form, okay, if your numerator is greater than your denominator, then you can simplify. Okay? So if your m is greater than your n, then that means you need to simplify. Okay? So my next example, I have 3 to the 1/4 times 3 to the 1/2. So I have 3. I'm adding 1/4 plus 1/2. So that's going to give me 3 to the what? That should give you what? 3/4. Okay, so then I'm going to rewrite it. I have the 4th root of 3 cubed. Okay, what's 3 cubed? 27. 3 times 3 times 3. Okay. I needed 4. I only had 3. I can't simplify that, but I would evaluate it because it's a number. Okay? If it were just a variable, I would leave it. You're good so far? Okay. 4 to the 1/2 raised to the 1/3. What am I doing there? I'm multiplying. 1/2 times 1/3. What does that give me? 1/6. So then rewrite it, and what is that? What's, the 6th root of 4. Do I need to put the 1? No. So just the 6th root of 4. Which I can't simplify because 4 is just 2 and 2. Okay? Now, I've got 7 cubed over 4 cubed raised to the negative 1/3. Okay? I'm telling you to use your properties. So I do not want you taking 7 and cubing it and getting a large number, getting 4 and cubing it, getting a number, and then distributing that negative 1/3. I do not want to see that. Okay? I am not evaluating until the very, very end. Okay? So what I'm going to do is I have 2 terms with an outside exponent. So I'm going to distribute that outside exponent. So I'm going to multiply 3 times negative 1/3, which just gives me negative 1. And then 4 to the 3rd raised to the negative 1/3 is the same thing. 3 times negative 1/3 is just going to give me another negative 1. Well, I have negative exponents. What do I need to do with those? So, because they are both negative, that 7 comes down, that 4 comes up, and my answer becomes 4 over 7. That's a whole lot easier than doing 7 cubed over 4 cubed, or whatever those numbers are, and then taking the cube root, and then flipping, all of that, okay? So when you have something like this, even though these are numbers as bases, I'm going to still use my properties and evaluate at the end, okay? All right, now this next example, I have 3 over x to the negative 5 halves. I don't have any outside exponent to do anything. I just have this problem. What's the only thing that's wrong with that problem? Yep, that negative exponent in the bottom. Okay, what do I need to do with that? Okay, I move it up. Does the 3 come down? No. The 3 has an exponent of 1. You only move the terms that have negative exponents, which just so happens to only be 1. So this just becomes 3 times x to the positive 5 halves. When you move it, it becomes positive. Okay? Now, I need to rewrite this. When I go and put it in radical form, does the 3 go underneath the radical? Or is it only the x? It's only the x, because that fraction exponent only applies to what's directly in front. Remember, I put a lot of emphasis on parentheses and knowing what's a base and what's not part of your base, right? That 3 was never originally part of that negative 5 halves. So when you put your answer together at the end in radical form, that 3 is still not part of that, okay? If it would have been in parentheses, yes, but it's not. So I'm going to have 3 times the square root of x to the 5th. Okay, can I simplify that? Yes. I have 5 x's. Your exponent tells you how many you have. Your index tells you you need groups of that. Okay, so I have a square root, so I need pairs of 2. I can pull out 2 pairs with 1 left over. Okay, so I'm going to have my 3. However many pairs you have of your variable tells you your new exponent. So if I have 2 pairs, x and x, that gives me x squared, square root of x. Bless you. Do y'all remember that in simplifying your radicals? Okay. Alright, so now I have the 4th root of x to the 12th over y to the 20th. If I don't have any outside parentheses, if all I give you is a radical, your goal is just to simplify. Okay? Now, remember that my rule tells me if I have a to the m over n, that's the nth root of a to the m. I can go backwards with that also. So notice that I'm taking the 4th root. It's the 4th root of x to the 12th over y to the 20th. I can split that, the 4th root of x to the 12th over the 4th root of y to the 20th. And I'm going to look at my exponents. Is my 12 divisible by my index? Yeah, if I were to rewrite it as a to the m over n, it'd be 12 over 4 over y to the 20 over 4. It's perfectly divisible. So x to the 12 over 4 is going to become x to the 3rd. 12 divided by 4 is 3. Okay? Y to the 20 over 4, 20 divided by 4 is 5. Okay? You could have listed 12 x's and 20 y's and done all your groups of 4 and counted them up. But always check to see if it's divisible. How many groups of 4 can I have out of 12? I could have 3. How many groups of 4 can I have out of 20? I could have 5. I don't have any left over. So that's my answer. Okay? Y'all good with that? Okay. Okay, what about the cube root of 135? I'm just giving you a radical. What do? I check to see is it a perfect cube. Okay, if all I give you is a radical, you always just start simplifying. Okay, is the cube root of 135 going to give me a whole number? Y'all know how to do the cube root, right? In your calculator? You should. You can do it two ways. You can do math 4, or remember you can do your index, which is 3, and then second, and then that button. So 135, it gives me a decimal. So that means I need to break it down. Okay? So I'm going to take 135, and I'm going to split that 5 and 27. 27 splits 3 and 9, and 9 splits 3 and 3. Okay, my index is 3. It's a cube root. So I'm not going to do pairs of 2. I'm going to do groups of 3. So your index tells you how many of the same factor you need to pull it out. Okay? So that means my 3 comes on the outside, and I have the cube root of 5 left over. So always check to see if it can be just a whole number when you type it in. So here I've got the square root of 5 over the square root of 125. Well, the square root of 5 is not a perfect square, and 125 is not a perfect square either. So anytime, no matter what, anytime you're given a fraction, you need to simplify the numbers under the radical, or try to, okay? I don't want to simplify using the radical because that's just going to give me decimals, okay? So what I'm going to do is I'm going to take my fraction template, and I'm just going to put the numbers, 5 over 125. Hold on. 5 over 125, and then hit the simplify. I forgot that part. Gives me 1 over 25. So I put that now underneath the radicals. So you simplify without radicals. Whatever your calculator gives you, that's what you put back under the radical. Now I have perfect squares. What's the square root of 1? 1. Square root of 25 is 5. If you don't simplify the fraction under the radical, then you're going to be simplifying the square root of 125 and then rationalizing. You can do it that way also, but it's easier if you just try to reduce the numbers and then you're left with perfect squares. Okay? So here I've got the 4th root of 243 over the 4th root of 3. I'm going to do the same thing. I have a fraction, so I'm going to type that fraction, 243 over 3. Oh gosh, we're all sneaking. And then I'm going to simplify it. It gives me 81. So I now have the 4th root of 81. Okay, well, what is the 4th root of 81? 3. Okay? If I was saying to evaluate or solve, then I would be doing plus or minus. But if all I'm saying is simplify, you don't need a plus or minus. Okay? Y'all good? Do we have questions? Okay. So if I multiply my radicals, cube root of 9 times the cube root of 12. As long as they're the same index, so the same root, I can multiply them. So I'm going to have the cube root. What's 9 times 12? 108. Then I'm going to go back to doing my prime factor tree. 108 will split into 2 and 54, which splits 2 and 27, 3 and 9, 3 and 3. It's a cube root. Even though I have 2 2's, I don't have 3 2's, so they're left over. So that becomes 3 times the cube root of 2 times 2 is 4. Okay? Now I've got 2 times the cube root of 12 times negative 4 times the cube root of 10. They're still the same index, same root. So I'm going to take my outside times outside. 2 times negative 4 is negative 8 times the cube root, 12 times 10 is 120. When you reduce that, you only reduce what's underneath the radical. I don't care about the negative 8 yet. So I'm going to take 120, and that splits 2 and 60, 2 and 30, 2 and 15, 3 and 5. It's a cube root, so I need groups of 3. My 3 and 5 are left over. Now, I know I'm pulling out a 2. What am I doing with that 2 and that negative 8? I'm multiplying. So I'm doing negative 8 times 2, which is negative 16, times the cube root of 3 times 5, 15. Okay? We good? I took the negative 8 times the 2, and then I did the 3 times 5 that was left over. If y'all need to write this step, if you're not sure how to go straight from here, if you need to write this, you can. But it's not necessary. Okay? Alright, rationalizing. You did very minimal rationalizing in Algebra 1. I remember we reduced that because that's a hard concept when you're in Algebra 1. Okay? Then in geometry, I know you did it with special right triangles. 45, 45, 90, 30, 60, 90 triangles. So if I gave you, let's say, the square root of 2 over the square root of 3. Okay? You should have been taught you cannot have a radical in the denominator. So you rationalize it. What do you rationalize by? The square root of 3, right? You multiply it by itself in the bottom. Okay. The reason you do that is because this index is really a 2. So your index is telling you you need 2 of the same number. I have 1 3, so I multiply it by itself because there's my 2 3's, and my denominator becomes 3, right? Okay. For some reason, oh, and this becomes square root of 6 because you just multiply. For some reason, everyone can rationalize square roots like this because you've been taught you just multiply it by itself. But in Algebra 2, we get to indexes greater than 2, and then everyone gets confused, okay? Your index tells you how many you need of the same number, okay? So if my index is 3, then I need 3 of the same number. If my index is 20, I need 20 of the same number, okay? So when I have the 4th root of 2 over the 4th root of 3, my index tells me I need how many of the same number? I need 4. I need 4 3's because my denominator is what I can't have, right? I need 4 3's. I have 1 of them. So how many more do I need?
3.
I need 3 more. What is 3 times 3 times 3? 3 times 3 times 3. 27. So I'm not going to rationalize just by itself. I have to consider how many more 3's do I need. I needed 3. So you multiply it all together. So I'm rationalizing by the 4th root of 27. That allows me to have 4 3's, right? So my 3 is what is now the denominator. My numerator is the 4th root of 2 times 27, which is 54. Okay? So if you need to go back to this, I had the square root of 3, and I multiplied it by itself because I needed 2. There's 1. I need 1 more. That's why you multiply it by itself. Now that I have a 4th root, I need 4. I have 1. I need 3 more. Okay? Y'all follow me? This is where a lot of people got confused, so you have to speak up if you don't understand. Say that louder. Here. Because what this is doing is I have the 4th root of 27 times 3 is 81, which is 4 3s. That's how that one factor comes out. Okay, just like when you do the square root of 3 times the square root of 3, it just leaves me with 3 because that's square root of 9, which is 3. So the whole reason you're identifying how many more you need, this factor, just this number, is what comes out.
So, like, for example, since it's cube, you would need, and you only have 1 5, you would need 2 more to make 3 to get the, okay, so that's like the effect. So, it just has to do with the actual number in the radical on the bottom. It's not like
So this next one, cube root of 8 over cube root of 5. Okay, well, I know the cube root of 8 is 2. I'm going to simplify that first. That's less I have to multiply underneath the radical when I rationalize. If you don't recognize it, that's okay. You're just going to simplify later on. But I know the cube root of 8 is a perfect cube. Okay, so here, my index tells me how many I need. I need 3 of this number. Okay, I need 3 5s. I have 1 of them. How many more do I need? 2. So 5 times 5 is 25. So I'm rationalizing by the cube root of 25. If all I did was rationalize by the cube root of 5, then I would only have 2, but I need 3. That's why you can't just multiply it by itself. Okay? Are y'all following that? Okay. So then my numerator becomes 2 times the cube root of 25 over, what's my factor? What was my goal? 3 5s. So my 5 is what comes in the denominator. You would check to simplify, you can't. So, why can I not simplify the cube root of 25? That's only 5 and 5, but your index is 3. If it was a square root, then yes, but a cube root I can't. Okay, and 2 and 5 can't simplify, so I'm done. Okay, so before I talk about the next one, I want you to, on the back of your notes, I want you to do the 4th root of 7 over the 4th root of 2. I want to make sure you understand this before I move on to the very next one. Okay. There's 3 questions you asked to do that. How many do I need? 4. How many do I have? 1. How many more do I need? If you write it like that, if you ask yourself those 3 questions, and you write it like this, then that's going to get you the number right here. If you break it down like that, it's not hard. But if you're not listening to me and you're not asking yourself those questions, then yes, it's going to be hard. Okay? Your index tells you how many you need. This is how many I have. I need 3 more. 2 times 2 times 2? 8. So the 4th root of 8. So 7 times 8. This is my factor that comes out. That's it. You do. You need 4 of the same number. Okay. Do we feel okay with that? Okay. So, now I have the 4th root of 3 over 4. I'm going to split that. The 4th root of 3 over the 4th root of 4. Okay. My index tells me I need how many of the same number? 4. Before you get all happy with doing 4 times 4 times 4, can you split 4 into 2 things? What can be multiplied to get 4? 2 and 2. If you wanted to break it down, you could. I need 4. If I think about 2's, I have 2 2's. So, if I need 4 and I have 2, then how many more do I need?
2.
I would need 2 more 2's. 2 times 2 is 4. If you don't recognize that that's a perfect number, that's okay. You could do what we've been doing. I have 1, I need 3 more, 4, 4, 4, that's 64, 4th root of 64, here's my 4, 3 times 64, 192. Then you would have to simplify. You can do this. If what we've been doing makes sense and you just want to see it as I have 1, I need this many more, don't worry about breaking it down. That's fine. Just know you have to break it down at the end. Okay? If you want less work and you can recognize your perfect numbers, you can look on the notes in the Google Slides. If you recognize your perfect squares and your perfect cubes, then you can absolutely do that. And then I'm just going to have the 4th root of 12 over my factor, which was 2. Which this will simplify to. Okay? So had you worked it out like this, you'd be doing 192, which splits 2 and 96. 2 and 48. This is a very long tree. You're doing the 4th root. Okay, so that would give me the 4th root. You'd have your 2 on the outside. 2 times 2 is 4 times 3 is your 12 over 4, which simplifies to 1 over 2, which gives me this answer. Okay? So you can do it both ways, but see how all that work you'd have to do versus if you can recognize your perfect squares and perfect cubes. Okay? I'm not telling you you have to do this. If what we did here made sense to you, then just keep on with it. Just know you're going to have to simplify later. Okay? Sometimes if you don't pay attention to this being broken down, it will give you a very large number. Very large. If you get a very large number, bless you, then that might give you a little hint. Maybe I could have broken it down. Okay? But are we good with this? Yes. Yes, that's 1/2. And that's how this comes over to. That's how it becomes the same answer. Okay, I know you had your hand up earlier. You're good? Okay. Okay. You only have 2 examples like this on the worksheet. So it's not going to be like a huge deal on your test, but it is going to be on your test. You have to understand that rationalizing, especially for whatever you take next year. Okay? All right. Adding and subtracting. When you multiply, you can do whatever as long as it's the same index. When you add and subtract, you have to have like terms. So it has to be the same index and the same number under the radical. Okay? So if I have 10 times the cube root of 6 minus 8 times the cube root of 6, this cube root of 6 is what's making it like terms. Okay? Think about 10x minus 8x. Those are like terms because of your x. And then how do I subtract that? 10 minus 8. I only do the coefficients, and that becomes 2x, right? My x never changes. So the same thing with this radical. It does not change. I only add and subtract my coefficients. So that becomes 2 times the cube root of 6. Okay? But if I don't give you like terms, you have to make them like terms. So I'm going to take this 32, the 4th root of 32, and I'm going to break it down. That's going to split 2 and 16, 2 and 8, 2 and 4, 2 and 2. It's the 4th root, so I need 4. That's going to leave me with 1 left over. So I have 3 times the 4th root of 2 minus, this becomes 2 4th root of 2. Yes? Okay. 3 minus 2 is 1, so I just left with the 4th root of 2. Okay? When I break these down, I already have a number outside. What would I do with the numbers already outside? Multiply them. Do we need to do this? No? We're not doing this one. Are y'all okay? Would you know how to do this? Okay. Now we're just putting it all together. Simplify. Okay, if all I give you is a radical, what do I always tell you? Break it down. Okay, but we check first. Is the cube root of 27 a perfect cube? Yes, cube root of 27 is 3. All right, I'm taking the cube root of x to the 4th. I have 4 x's. I need a group of 3, so that leaves me with 1. So my answer would be 3, pull out the x, then cube root of the x that's left over. Okay. 5th root of 4, a to the 8th, b to the 14th, c to the 5th. 5th root of 4, I can't simplify that. Okay. A to the 8th, I have 8 a's. I need a pair of 5s, a group of 5s. That leaves me with 3. If you can do the mental math between your exponents in your head, then you don't have to list everything out. Like if I'm looking at 8, me personally, how many 5s can I get out of 8? 1. I got 3 left over. Okay? So that means an A comes out. And now I'm going to have 4 from the fifth root of 4. I have 3 A's left over, so that's A cubed. Okay. How many groups of 5 can I get out of 14 for my B? 2. So that would be B squared that comes out. How many would be left over? If I have 14, I took out 2 of 5's, then that leaves me with 4. Again, if you need to list it out, you can. All right, the fifth root of C to the fifth is just C. If you can't do it in your head, write it out. Don't make a mistake just because you were being lazy and didn't want to write out 14 B's. Okay? All right, square root of x cubed y squared z times the square root of x to the fourth y z to the fifth. I'm multiplying. So what do I do with my exponents? I add. So x to the third power times x to the fourth is x to the 3 plus 4 is 7. Y squared times y, 2 plus 1 is 3. Z and z to the fifth is z to the 6. Then I simplify. What's my index? 2. How many pairs of 2 can I get out of 7? 3. So I pull out an x cubed. And I have 1 left over. Square root of y cubed. How many pairs of 2 can I get out of 3? 1, and I have 1 left over. Y'all follow how I'm doing this? Okay. How many pairs of 2 can I get out of 6? So z cubed with none left over. Three times the fourth root of 10x to the fifth times negative 2 fourth root of 8x. What do I do? Outside times outside, radical times radical. 3 times negative 2 times the fourth root of 10 times 8. 80x to the 6. Then I break down my 80. 2 and 40, 2 and 20, 2 and 10, 2 and 5. I need 4, so I'm left with a 5. So negative 6 times the 2. Okay, I need 4 out of 6. How many groups am I going to have? Just 1. And I'm going to have my 5 left over. How many x's am I going to have left over? 2. I had 6. I took out 4. Got 2. Alright, so that becomes negative 12x, fourth root of 5x squared. So here I have 6 x's. I need a group of 4. So that one group comes out, and I got 2 left over. And then the negative 6 from multiplying 3 and negative 2, that comes down, and I multiply it by the 2 that I pulled out. And that's how I get my negative 12. Y'all good? Okay, the moment you see a fraction, what do you try to do?
Split it.
Simplify your numbers. Okay? 27 over 4, can that simplify? No. But can I simplify x to the 5th over x to the 4th?
Yeah.
Okay. So I'm going to simplify and split all in one step. Okay. So I know I'm going to have my 27. I know I'm going to have my 4. When I simplify x to the 5th over x to the 4th, what am I doing with those exponents? Subtracting. 5 minus 4 is 1. It's positive, so where does it go? Top or bottom? Top. And then y and z cannot be simplified, so y and z cubed. So I simplified my x's. Now I'm going to do whatever I can to simplify everything else. So my numerator, square root of 27. I know 27 is 3 and 9, which is 3 and 3. It's a square root, so I need a pair. So that becomes 3 times the square root of 3. I only have one x I can't do anything with. I only have one y I can't do anything with. Are you good with that? Okay. Now the bottom, square root of 4 is what? 2. Then I have z cubed. So I have 3 z's. I need a pair of 2. That leaves me with 1. So I'm pulling out a z from the pair that I made. Then I have the square root of z left. Can I leave it like that? I gotta rationalize. It's the square root of z that I need to get rid of. I don't care that 2z is in my denominator, but I cannot have the square root of z. So what do I rationalize by? The square root of z. I need 2, I have 1, I need 1 more. So I have 3 square root of 3x, y, z. My denominator, I have a 2. Square root of z times the square root of z is z. Z times z is z squared. Even though it looks like I can reduce these z's, I cannot because this numerator is under the radical. It's under the radical, and in my denominator I cannot do that. They would have to both be under the radical like x and x was. Okay? We good? Okay, that's 6.2.